let us work out a few numericals on relations. First example, let me see. Okay. First example, R is a relation on Z defined by R is equal to x cubed, such that x is a prime number less than 12. I'm repeating. R is a relation on Z defined by R is equal to x cubed, such that x is a prime number less than 12. You have to find R. Write down the domain and range of R inverse. Unless you find R, you cannot find R inverse. Okay, so directly it's written. Write down the domain and range of R inverse. Now what does it mean? If x, solution, if x is a value that I will take from the set of prime numbers less than 12, then y has to be x cubed. Y is the second component, right? So what are the values of x that I can take? Prime numbers less than 12. I think I'll write directly. Prime numbers less than 12, what are they? One is your 2, then is your 3, then is 5, then is 7 and 11. Nothing more, isn't it? So these are the prime numbers less than 12. This is what we have chosen as x. So what are the corresponding values of y? This will be 2 cubed, isn't it? So that is how much? 8. For this you will get 3 cubed. That means it is how much? 3 cubed? 27. For this it is 5 cubed. That means it's 125. For this it is 7 cubed. That is 49 into 7. That gives us 343. And for this it is 11 cubed, which gives us, I think I'll put an arrow instead, which gives us how much? 1331, isn't it? So these are the values of y that we have. For 2 it is 8, for 3 it is, for 2 it is 8, for 3 it is 27, for 5 it is 125, for 7 it is 343, for 11 it is 1331. So what is the required? This is your second component and this is your first component. So let us list R. We can do that easily. We can write it in roster form very easily. That is, we'll write it in pairs obviously. So what are the pairs? 1 minute. The screen has become little. Okay. Listing values of R, the pairs. The first one is 2, 8, 3 with 27, 5 with 125. Do we have space there? We have 7 with 343 and 11 with 1331. So this is your required relation that is there, which is now listed in listed form. So what is R inverse? R inverse, you know, it's just the first components become the second components, the second components become the first component. So 2, 8 is going to become 8, 2. 327 becomes 27, 3. Next one becomes 125, 5. The next one becomes 3, 4, 3 and 7. The next one becomes 1, 3, 3, 1 and 11. So this is your R inverse. And hence, what is the domain of R inverse? Domain, you know, is the set of first components. So first components of R inverse. First components of R inverse. What are they? 8, 27, 125. I will write it. 8, 27, 125. 3, 4, 3 and 1, 3, 3, 1. So these are this constitutes the domain of R inverse. Then comes, what else did they ask? Range of R inverse. Range of R inverse is the second components of R inverse. Okay, and what are the second components over here? That is 2, 3, you can see from here, 2, 3, 5, 7, 11. So range of R inverse as it is supposed to be domain of R. You can check and see it is the domain of R, because this is the values of X will constitute the domain of R. So, and domain of R inverse is supposed to be the range of R you can see. So this is what we have. Okay, we move on to the next question now. The next example is, write it here, example number 2. A set is given whose elements are 1, 2, 3, 5. Another set is given whose elements are 4, 6 and 7. They are saying that define a relation R from A to B by R is equal to xy such that difference between x and y, can I write till there? Yes, is odd. Okay. R is the set of ordered pairs xy such that the difference between x and y is odd. Okay. Of course, x belongs to A and y belongs to B. That is obvious. Y also belongs to B. So I think so, and they are saying in roster form. ROSTERFOR. Define a relation R from A to B given by this in roster form. Okay. So, what are they saying? R is the relation from A to B. That means the first components have to be from the set A. Not only that, since we have two sets here, we know it is supposed to be a subset of A cross B. So to be on the safe side, what we can do is, and not only that, they are saying that R is such that the difference, they are not saying the positive difference or what. Difference means what? It can be x minus, so if I take two numbers, x and y, I can consider it as x minus y, I can take the difference as y minus x also. They are not saying positive difference as such. The main thing is that, so I'm using this symbol, this is called symmetric difference, okay? So x minus y is odd. This means what? That means difference between x and y is odd. That means if I take x minus y, then also it's odd. If I take y minus x, then also it's odd. Okay, that is how it is supposed to be. So the best option is, you can choose values of x one by one. You can choose values of x from A, of course. I'll mention that, where x belongs to A and y has to belong to B. A is the set 1, 2, 3, 5. B is the set 4, 6, 7. So you can do it directly by choosing values of x. When I take 1, I have to consider difference with 4 and see whether it's odd or not. I have to consider difference with 6 and see whether it's odd or not. I have to consider difference with 7 and see whether it's odd or not. Then I have to take 2. Check the difference between 4 and 6 and 7, whether it's odd or not. So that way you can do it mentally. Otherwise, what you can do is, first you list what are the elements of A cross B. Then you will not miss out any of them. What are they? First of all, it's 1, 4, 1, 6, 1, 7, 2, 4, 2, 6, 2, 7, 3, 4, 3, 6, 3, 7, 4, 4, no not 4, sorry, 5 is here, 4 is not there, 5, 4, 5, 6 and 5, 7. So this is A cross B, out of which we will take those pairs which satisfy the condition that their difference is odd. What are they? Difference between 1 and 4, it's 3, it's odd. Difference between 1 and 6, it's 5, plus minus 5, whichever order you take it. So it's odd. 1, 7 is even, so I'll not take. This is even. This is going to be even. 7, 2, this is odd. I think I'll underline. Okay. 3, 4, this is 1, this is odd. This is 3 difference, so it is odd. 3 and 7, the difference is, it's 9. I got 7. Okay. 3 and 7, the difference is even, so I will not take it. Here the difference is odd. Here the difference is odd, and this is even. Difference between 5 and 7, it is even. Whether I take it as 5 minus 7 or whether I take it as 7 minus 5, the difference is plus minus 2. So it is even. I will not take it. So what is R therefore? R will be the elements 1, 4, 1, 6. Okay. Then 2, 7, 3, 4, 3, 6, 5, 4 and 5, 6. This is your answer. This will put less stress on your brain, isn't it? So you can do it like this. Otherwise, you do directly. Consider 1 with 4. Mentally, you will think whether the difference is odd or not, and you will write it over here. 1 and 6, 1 and 6, yeah. You will consider the difference in your mind and see it's odd, so you will list it. 1, 7, you will consider, check the difference, think of it. It's not even, it's not odd, so you will not write it. Then move on to 2. 2 and 4, the difference is even, so you will not list it when you are doing it directly. Okay, so like that. So this is the next example. Let us do another example after this. That is, the question says a relation R is defined on a, how far can I write, on a set A, which is equal to 4, 5, 6, 8 to a set B, I read B below, which is 2, 3, 4, 5, given by R is equal to AB such that A belongs to A, B belongs to B, and A is divisible by B. This is the relation that is defined. Find the domain and range of R. Okay, find the domain and range of R. I'm reading it out once more. A is a relation. Define a relation R is defined on a set A given by this to a set B given by this, and the relation R is such that if I take the components A, B, then the first component A is divisible by the second component B. Okay, so you're asked to find the domain and range of R. So, what do we have? The first component A has to belong to the set A, which is 4, 5, 6, 8. And the second component has to belong to the set B, which is 2, 3, 4, 5. Not only that, R is the relation defined by A is divisible by B. That is, the first component has to be divisible by the second component. In other words, if the first component is divisible by the second component, it means the first component is actually multiple of the second component. Isn't it? Only then it will be divisible. The first component, any number is divisible by another number if and only if it is a multiple of that number. So we will consider numbers such that the first component is multiple of the second component. Okay, so two ways of doing it. As usual, you can do it directly. First, take the element 4, check 4 is divisible by 2. Yes, so 4 2 will form a pair. 4 3 is divisible by 2 4 3 is not divisible. 4 is not divisible by 3, so it will not form the pair. 4 and 4, it's divisible, so this pair will be taken. 4 and 5 not divisible, it won't be taken. Next, move on to 5. 5 2 not divisible. 5 is not divisible by 3, so won't be taken. 5 is not divisible by 4, so won't be taken. 5 is divisible by 5, so that pair will come into account. So 5 5 will be the next component, like that. Okay. Otherwise, if you're not confident, then in case you miss out something, just to avoid that, you can do A cross B first. That is, what are the elements of A cross B? With 4, you have 4 2, 4 3, 4 4, 4 5. With 5 now, 5 2, 5 3, 5 4, 5 5. With what next element? 6, 6 2, 6 3, 6 4, 6 5. 6 2, 6 3, 6 4, 6 5. Then 8, 8 2, 8 3, 8 4, 8 5. Hello? So therefore, these are the components of A cross B. So what is R therefore? The required relation R, I shift it on this side. Required relation R is, I will take only those pairs where the first component is divisible by second. Here, here, then this. First component divisible by second, first component divisible by second. This is a fraction, it's going to become, so I will not choose. First component not divisible by second, first component divisible by second, first component divisible by second. So these are the pairs that I will take. So it's 4 2, 4 4, 5 5, 6 2, 6 3, 8 2, and 8 4. So this is your I won't say this is your answer, this is the set R. Okay, so what is the domain of R and what is the range of R? Domain of R is the set of first components. That means it's 4, don't repeat, 5, it's going to be A itself, 6 and 8. It's supposed to be A, it is A, so no problem. Range of R, the values of Y that you got, what you got, 2, 4, 2, there's a 3 also over here, right? So you will write 3 first, 2, 3, 4, what else? 2 is there, 3 is there, 4 is there, 5 is also there. 2, 3, 4, 5. So here notice range is the same as the codomain, isn't it? So I'll do one thing, I'll write over here, this is equal to A and this is equal to B. B is the codomain. In this, can you see? You cannot see, I think. I'll write beside it. B is the codomain. Okay. So this is what we have. That is, the range of R is the same as the codomain in this particular case. And the domain of R is always going to be the first set, that is the set A. Okay. So we move on to the next example now. Example, what do we say? Okay, A is the set 1, 2, 3, 4, 6. Okay, and R is a relation. R is a relation defined on A by R is equal to AB such that AB, here we have a single set now, AB belongs to A and B is exactly Okay, B is exactly divisible by A. B is exactly divisible by A. Okay, and they are saying write the relation R in roster form. Write the relation R in roster form. This is the question. So definitely there's a single set here. So actually R is going to be a subset of A cross A, and R is a relation from A to the set A itself. There's no other set over here. So I have to consider those pairs where the second component is divisible by the first. So best option is you better list A cross A. Otherwise halfway through you will get confused and you will not be sure whether you have taken all the pairs that are possible. What is A cross A? It is cross between 1, 2, 3. If you can do it mentally directly, well and good, no problem. Okay, 1, 2, 3, 4, 6. So it is 1 with 1, 1 with 2, 1 with 3, 1 with 4, 1 with 6. Similarly, 2 with 1, that is the next element 2, 2 with 2, 2 with 3, 2 with 4, 2 with 6. Okay. Similarly, 3, 1 up to dot 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 up to 3, 6. Okay. And you have 4, 1 dot 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 up to 4, 6. What else? 4 I have taken, then 6. Then you will have 6, 1 dot 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 up to 6, 6. So these are the elements that you will have. You want me to write the entire thing? I can write, no problem. That is, it is 3, 2, 3, 3, 3, 4, and 3, 6 is already there. Here it is going to be 4, 2 next, 4, 3, 4, 4, 4, 6. Here it's going to be 6, 2, 6, 3, 6, 4, and 6, 6. So this is what we have. Okay. So out of these, we have to choose those pairs where the second component is exactly divisible by the first component. So let us see. Second component 1, yes, it is divisible by 1. 2 is divisible by 1. 3 is divisible by 1. 4 is divisible by 1. 6 is divisible by 1. Here 1 is not divisible by 2. Be careful. Here R is, B is exactly divisible by A. That means in this case, second component is exactly divisible by the first component. This is what we have. So therefore, what are the components we are listing? 1 is not 2, 2, yes. 3 is not exactly divisible, 4 is exactly divisible, 6 is exactly. Just select the second components and judge whether it is divisible by the first component. Okay. 1 is the second component, not divisible by 3. 2 is the second component, not divisible by 3. 3 is the second component, divisible by 3. This is not divisible by 3. 6 is divisible by 3. 2 is not divisible by 4, 3 is not divisible by 4, 4 is divisible by 4, 6 is not divisible exactly by 4, 1 is not exactly divisible, 2 is not exactly divisible because it's going to give me a fraction 1 by 3, 3 is not exactly divisible because it's going to give me half. And what else? 6 is also 4 is also not exactly divisible, but we will have 6, 6. So what is R? R is the set of components 1, 1, 1, 2, 1, 3, 1, 4, 1, 6, followed by 2, 2, 2, 4, 2, 6, followed by 3, 3, 3, 6, and then you have 4, 4 and 6, 6. So this is your answer for R to be written in listed form or roster form. Okay. The next example, that is R is, I'm just writing the relation, okay, xy such that x is an integer, okay, x is an integer, mod x is less than 3, can I write that side? No. And y is equal to mod of x minus 3. Okay, R is xy such that x is an integer where mod x is less than 3 and y is mod of x minus 3. So, how will you find the set R? Because you have to write the set in roster form. The entire question I am not writing. My target is to list this set. Now, you must remember the definition of mod function. Can you see? Yes, you can see. What do I have? I have two equations. Mod x is less than 3 and the other one is y is equal to mod of x minus 3. Okay. This means that value of x can be, if it had been equal to 3, then mod x would have been either plus 3 or minus 3. But since it is less than 3, that means x value will lie in between these two. Okay, so this will mean that minus 3 is less than x less than 3. Okay, by virtue of definition of modulus. Okay. Similarly, if y is equal to, here we have equal to sign, not less than sign. So therefore it means y has to be plus minus of x minus 3. Or you can say x minus 3 value has to be plus minus y. That way also you can write, because when it is plus y, then modulus of x minus 3 will be y. When x minus 3 value is minus y, then also modulus of x minus 3 is going to be y. So you can write that x minus 3 value will therefore be either plus y or minus y. You can write y is equal to plus minus x minus 3 also. Okay, both are correct. So let us see, we have two expressions over here, one for plus sign and the other one is for minus sign. So what do we have here? So here we have to list, therefore we have to list the second components, that is, I think that is y is equal to x minus 3. This will give me the second components over here. I'll draw a line and y is going to be, y if I write it this side, it's going to be minus x plus 3, or you can say it is going to be 3 minus x. So these are going to give me the second components. Okay, so I'll draw a double line in between, that is, it's a little crooked. Can you see? I don't think you can see. Now I think it's alright. This line is crooked. I'll try to make it straight as far as possible. Okay. Okay, so let us choose the values of x. So what are the values of x therefore? X is an integer they are saying, so I can take integer values fortunately. So values of x are lying between minus 3 and 3, excluding the point minus 3 and 3. Be careful about that. So value of x is actually minus 2, minus 1, 0, 1 and 2. Okay, so for this is the domain. We know that x is supposed to be the first components. So for these values of x, what do we get the values of y? We will see that over here. So let us write it. That is, what is the first value of x? X is minus 2, isn't it? So we take the first value of x, that is minus 2, and write it here. For x is equal to minus 2. What is the value of y over here? Y over here is minus 2 minus 3. That gives us how much? Minus 5. Whereas y over here is 3 minus of minus 2. Be very careful. Can you see? Yes. It's 3 minus of minus 2. That means 3 plus 2. That is 5. Next. For x is equal to minus 1. Value of y is minus 1 minus 3, that is minus 4. Value of y over here is 3 minus of minus 1, that means it's plus 4. Okay. For x is equal to 0, y value, we can do it mentally, 0 minus 3, that is minus 3, and y over here is 3 minus 0, that is 3. For x is equal to 1, y is equal to 1 minus 3, that is minus 2, and over here y is equal to 3 minus 1, that is 2. Okay, for x is equal, you can do this mentally also, it's not necessary that you have to write and do. This is 2 minus 3, that is minus 1, so y is equal to 3 minus 2, that is 1. So what have we obtained? In fact, for x is equal to minus 2, we have obtained minus 5 and 5. For x is equal to minus 1, we have obtained y value as minus 4 and 4. For x is equal to 0, minus 3, 3. For x is equal to 1, minus 2, 2. For x is equal to 2, minus 1, 1. So let us list it. So when we are listing it, what do we get? R is equal to minus 2, minus 5, minus 2, 5. Okay. For minus 1, it is minus 1. What did we get? Minus 4. The other value is minus 1, 4. Next, for 0, 0, minus 3, 0, 3. And for 1, it is 1, minus 2, 1 plus 2. And we got 2 minus 1, 2 corresponding to 1. So this is what we have. In fact, you could have written it, this is your answer actually. So you could have written it like this, that minus 2 plus minus 5, like this also. Like these two can be merged together. These two again, minus 1 plus minus 4. This way also you can write, okay. No need, we have written it explicitly. So this is your required relation and this is your answer for this particular question. You just have to remember the definition of modulus. That's only then you will be able to apply. Okay. A relation R is defined by this, that is x square plus y square is equal to 25. It is defined on a set of integers z by xy such that x square plus y square is 25, where obviously xy has to belong to z, and you've been asked to find the domain and range of R inverse. For particular values of x, you are supposed to find the particular values of y so that you can write it in pairs. Okay, so what we are doing is, for the equation, there's an equation over here, x square plus y square is equal to 25. We are making y as the subject. Y square is 25 minus x square, or y is root over of 25 minus x square. So this is what I have. Now I will choose, in fact it will be plus minus because we are considering integers, it can be plus as well as minus. So we will see what are the values of x. And accordingly we will get the values of y. So if x is equal to 0, what are the values of y? Root over 25 minus 0 plus minus, that gives us plus minus 5. If x is equal to 1, will we get anything? No. Y will give us what? Root over 25 minus 1, and it's not going to be an integer, so we will not. It is irrational. I'll write it, but root over plus minus 24, which is therefore going to be irrational number, and therefore we are not going to take it. Okay. Others I will not write. We will do it mentally. Okay. When I take the value of x as next value is what? I can take plus 3 as well as minus 3 because it is an integer, and whether I put plus 3 or minus 3, it's going to be 9. So I'll get the corresponding value of y as 16, that is plus minus. So the corresponding value of y is going to be root over of 16, that means it's plus minus 4. Next value, what will it be? I'm sure you'll be able to do it mentally. If I take x as plus minus 4, the corresponding value of y is going to be plus minus 3 because 25 minus 16, that gives you plus minus 3. If I take the value of x as plus minus 5, value of y is therefore, what is it? 25 minus 25, that is 0. Plus minus 6 if I take, will it work? No, isn't it? This is going to be root over plus minus 25 minus 36. That is going to be something negative. That is plus minus, I'll just write root over negative, which is not a real number. So forget being an integer, isn't it? Which is not a real number. So therefore, I cannot take this value. And in fact, if I take values greater than this, then also it will remain negative. That is, it's going to give me complex or imaginary numbers. So therefore, I will not take the rest of the values. Okay. So therefore, what are the, let's list what is the value of R, what is the set R. Let us list it. So the set R, that is the relation R, is therefore, I'll write it below. Can you see? Yes, you can see. R is equal to, what is it? When x is 0, y is plus minus 5. You can write it as plus 5 and minus 5 separately, because as it is, we have to list it. Okay, or shall I merge? The previous sum I did not merge and write. This one I am writing it merged. That is 0 plus minus 5. When it is 1, oh, we don't have 1, sorry. When it is plus minus 3, it's going to be plus minus 4. When it is plus minus 4, it's going to be plus minus 3. When it is plus minus 5, it's going to be 0. When it's plus minus 6, it's, sorry, 6 we don't have. So this is where we stop. In fact, if you list it more explicitly, what should you write? There will be 4 of them coming out from here. I hope you are aware of it. Yes, there will be 4 values coming out over here. That is, actually you will have, from here you will get 2. That is 0, 5 and 0 minus 5. Okay, whereas over here when it is 3, it is 4 as well as minus 4, isn't it? Because here it's plus minus. So when you're taking 3, it's going to be plus 4 as well as minus 4. When you're taking minus 3, it's going to be plus 4 as well as minus 4. So therefore, here you'll have 4 of them. 4, 3, 4, 3 minus 4. And can you see, I'll write it this side. When I take minus 3, it's 4. When it's minus 3, it's minus 4. I hope you have understood why. In fact, if you want, you can draw a tree diagram also, and that will be easier. That is, what you have over here is, it's 0 with 5 and minus 5. 3, 4 minus 4. Minus 3 also, you will get 4 minus 4, isn't it? When it's 4, you will get 3, 3. When it is 3 and minus 3, sorry, 3 and minus 3. When it is minus 4, then also you will get 3 and minus 3. When it is 5, you will get 0. When it is minus 5, then also you will get 0. This is differently represented. Okay, so actually what do I get over here? So it's minus 3 minus 4 already written. Then you have 1, 2, 3, 4, 5, 6, 4 is left. So you have 4, 3, 4, minus 3, minus 4, 3, can you see? Minus 4, minus 3, then you have 5, 0 and minus 5, 0. So this is the set, or this is the relation which is written more explicitly. Okay, and if you write it in compact form, you can write it like this, but be careful, you should be aware of its meaning. If you're writing it like this, you should be aware of the fact that actually it is 0, 5, 0, minus 5. When it's plus 3, it's going to be plus 4 as well as minus 4. When it's minus 3, it's going to be plus 4 and minus 4. So you'll have 4 over there. From here again, you'll get another 4 for plus 4, you will get plus 3 and minus 3. For minus 4, you will get plus 3 and minus 3. And here, of course, it will be 2 of them. That is 5, 0 and minus 5, 0. Okay. So this is your R. What is the domain of R? Domain of R. It is the set of the first components. Did they ask you domain of R? I don't think so. Let me check once more. No, they are asking you domain of R inverse. So you can write R inverse after this. That will be better. R inverse, let us list it, what it is. R inverse is therefore just the reverse. That means 0, 5 is going to become 5, 0. this is going to become minus 5, 0. This is going to become 4, 3. And this is going to become minus 4, 3. The next one, this is going to become 4 minus 3. This one is going to become minus 4 minus 3. This is going to become 3, 4. This is going to become minus 3, 4. This is going to become, this one now, 3 minus 4. And this one, that is minus 4 minus 3, is going to become minus 3 minus 4. The next one is 0, 5. The next one is going to become 0 minus 5. So this is your R inverse. How many you have? 12 of them. Okay, so what is the domain of R inverse? Domain of R inverse is going to be the first components. What are they? 5 and minus 5, so plus minus 5, 4 and minus 4, plus minus 4, already taken, 3 and minus 3, so it's plus minus 3, already taken, and of course 0. So this is your domain of R inverse. Okay. And what about domain of R? Domain of R, obviously, it's going to be 0, plus minus 3, plus minus 4 and 5. Okay, so this is your answer. They have asked you to find domain of R inverse. So unless you find R inverse, you cannot find its domain. Or from this itself also you can write, that is range of R is the domain of R inverse. So you can write over here, domain of R inverse is equal to range of R, and range of R from here you are getting, it is plus minus 5, plus minus 4, plus minus 3 and 0. So that way also, if you want, you can write. Okay.